In this example, we're being asked to draw the Bohr and electron dot diagram for a magnesium atom and ion. Our first step is to locate magnesium on the periodic table. Here we see magnesium is atomic number 12. That indicates that there must be 12 protons in magnesium's nucleus. We also notice that it is in period number 3, so it has 3 shells of electrons, and it is in group number 2. So we have 2 valence electrons in that outermost shell. If we take a look at a magnesium atom and its Bohr diagram, here we see those 12 protons in the nucleus, and since the atom is electrically neutral, the number of protons must equal the number of electrons. So we have 2 electrons in the first shell, 8 electrons in the second shell, and 2 electrons in that outermost shell, giving us a total of 12 electrons. So we have 12 positive charges and 12 negative charges. The magnesium atom is electrically neutral. Now when we draw the electron dot diagram or Lewis dot diagram, we're just drawing those outermost electrons or the valence electrons. And here we see them in purple. There are 2 of them. So in that electron dot diagram, I place those 2 electrons there. Now when we're taking a look at the magnesium ion, we know that the ion wants to have a stable configuration and have 8 electrons in its outermost shell. So it can do that one of 2 ways. It could potentially gain 6 electrons in this outermost shell to have a full octet, and that would be difficult to do. Instead, what we'll see is the magnesium atom will want to lose these 2 electrons in this outermost shell so that it has a full valence shell and octet. And that's what we see with the magnesium ion. Here we have a full valence shell. There's 8 electrons, but now we don't have equal number of protons and electrons. We still have those 12 protons that are in the nucleus, but we only have 10 electrons in those shells. So we have a positive 12 charge and a negative 10 charge, so a difference of positive 2. That's why when we draw the electron dot diagram, we write down the element symbol, we put brackets here, and then we write that electrical charge outside of the brackets. In this case, it's 2+, indicating that we have more protons than electrons by a number of 2. 12 protons versus 10 electrons, giving us an overall difference of positive 2. So that's how you draw the Bohr and electron dot diagrams for a magnesium atom and ion.